Hello, my name is Maxwell Bowman. I'm a chemistry teacher at John Marshall High School, and today I will be covering the material for packet number 2. We look at a positively charged particle over here and a negatively charged particle over here. They are going to have attraction. They like each other, opposites attract. But if we have one positive over here and one positive over here, well, they don't like each other. They're going to stay as far away as possible. What about negative charges? Two negative charges? Same thing. They don't want to get together. Opposites attract. Another important thing to look at for Coulombs Law is distance. So when you look at the distance between the particles, well, the closer together they are, the stronger the force gets. The further apart they are, the weaker the force gets. Let's take a look at a simulation so we can actually see these ideas in action. You can see I've got one negative charge and one positive charge. They're both attracted towards each other. But as I change that charge to make them both positive charges, you can see that the arrows now point out. They're unattracted to each other. They're repelled. I can change all of my values for charges and see how that affects the forces. The charges we're looking at right now are also very small. That weird U, that's a micro. We're looking at micro charges, microcoulombs, very, very small. Another important thing to look at is the distance between charges. As I pull them further away, the force gets smaller. As I push them closer together, the force gets much bigger. Let's also take a look at some of the properties of atoms on the periodic table. Right now we're looking at their radius. That's how big the atom is. We can see that hydrogen is 53 picometers, whereas lithium is 167. So lithium is clearly a lot bigger. As we go down the periods, we get bigger atoms. What about when we go left or right? Well, if we look at fluorine and neon, as we move to the right, our atom gets smaller. So the general trend we see on the periodic table is that atoms will get bigger the further to the left and the further down they are. Another trend we can look at on the periodic table is electronegativity. We can see that there's a trend of increasing electronegativity as we go to the right on the periodic table and as we go up. Electronegativity represents how easy it is for an atom to pull off some valence electrons. And with that, as the final part of our investigation for this week, stay tuned next week to see what we have in Packet 3.